In this session, we're going to look at the applications of organic chemistry, specifically esterification and combustion. In your textbooks, that's page 100, but you can follow along as we go along. Now, esters have a very pleasant, characteristic smell. Well, pleasant being relative sometimes, okay, and they have a characteristic smell. We see them in nature, in fruits and flowers. It's the things that are responsible for the why bananas smell like bananas or apples smell like apples, okay. Now, the reaction to create esters is known as an esterification reaction, and it's a reaction between a carboxylic acid and an alcohol. But what's really important in these reactions is we must have sulfuric acid. Of course, it acts as a catalyst, and what we need to remember here is that a catalyst speeds up the reaction. Okay, that's really important. These reactions would happen, but without the sulfuric acid, and it's a very concentrated sulfuric acid, it takes quite a long time. If we now look at the general formula for what is happening here, we have a carboxylic acid plus an ester, which is going to give us an alkanoate. That's just a word to remember actually how to name an ester. It's just a very fancy word for an ester. We could write it as an alcohol plus a carboxylic acid gives us an ester plus water. Okay, sometimes this is known as a condensation reaction because we get water. What's very important here is we cannot leave out the fact that we have H2SO4. It is a catalyst, so we put it on top of the arrow. The next line shows us as a condensed structural formula. So it's showing me here the structure of my alcohol. Over here it shows the structure of the ester, the carboxylic acid. There's my ester, and of course we get water. When we look at it as a structural formula, what's important to realize what is actually happening here, and this is what makes this so nice, is that the H comes off the alcohol, the OH comes off the acid. Together they form the water. Now, please don't forget, water is a bent molecule. You cannot write it as a straight molecule. This also helps me when naming. Remember, when we name, that part would be the alkyl part. That comes from the alcohol. That side comes from the carboxylic acid and would be the anoate part. Okay? So, we're going to look at a couple of examples. It says, use a structural formulae. That means write it out properly. Write a balanced equation for the esterification reaction that occurs between ethanol and propanoic acid. So, before we do anything else, let's start with the ethanol. Okay? So, ethanol, 2 carbons with the OH. That's ethanol. We all good with that? Not a problem. Now, you would all write this in one line. I'm probably going to run out of space. Plus, the next one we've got is propanoic acid. Prop being 3. All right, and we have the oic acid. So there we go. Okay, with the double bond oxygen. Now, we've already done half of what's going on. What we have to remember now is this. The H is going to come off the acid, and the OH is going to come off the carboxylic acid, which then means, please, you will write this in one line, not in two. We start again where we had the ethanoic. So we have C. Then we keep in the oxygen. Now, I'm going to turn this one around because I can't have the double bond oxygen at the end. Goes to the double bond oxygen, and now there's 3. Okay? So there we go. And don't forget all our hydrogens. Very important. We know this. But of course we're not done because we will always create water. Okay? That is a structural formula. It is naturally balanced. You don't need to do anything to balance it. If they then asked you what the name of the organic compound is, well, you wouldn't even have to draw it to get the name because it would be ethyl propanoate. Ethyl propanoate. And water. That's the organic compound. Water is not. Let's try another one. Use structural formula to write the balanced equation that occurs between butane 1-ol and ethanoic acid. Now, what's really important here is we have to use an alcohol that has the OH at the end, okay? Specifically for our curriculum, obviously in the real world it doesn't always have to happen like that, especially with more complicated esters, but that's what we're using at this point, so that's what we're going to stick to, okay? So butane 1-ol, so we've got butane, which is 4 carbons with, let's put the oxygen over here because it actually doesn't matter, okay, whether it goes up or down. Let's just see in the last one, did I put in all, yes I did. Sometimes I've got to check if I put in all the hydrogens. Alright, so there we go. Here we have all our hydrogens. Alright, we're all happy with that. So that's the butane 1, 2, 3, 4. Then it's ethanoic acid. Alright, so F. Okay, ethanoic acid, double bond oxygen. Now, as I'm doing this, I'm realizing I forgot something out, which I'm hoping some of you were paying attention to in the last one, in that I forgot to put the H2SO4 on the top. Okay, please don't do that. You really need it. So, butane 1-ol and ethanoic acid becomes, so we have 1, 2, 3, 4. Then we're going to have the oxygen, 2 carbons afterwards because that's the ethanoic acid. Don't forget all your hydrogens. And then, of course, we have here, and without forgetting, we always create water. Now, of course, this one's easy to name because the alcohol we used was butanol. So that means when we name this, this becomes butyl ethanoate. Okay? Now, at this point, if you want to pause the video before we do the next one and see if you can do it, that would be great. Otherwise, just carry on. There we go. Now we're asking this in a slightly different way. So they say use structural formula, write a balanced equation for the production of propyl methanoate. Now, this is really important because we can ask you it in lots of different ways. First thing you need to recognize is the propyl means that I had propanol. That gives me the name of the alcohol. Propanol being 3. 1, 2, 3. Okay. So now we've got the alcohol part. The only thing that makes this a little bit more difficult is the fact that we didn't tell you what we started with. Okay. Then the next one is methanoate. Okay. Methanoate. That means it comes from methanoic acid. Okay, so that's the carboxylic acid we used. Methanoate means that there's a single carbon. Alright. Oh, no, I'm about to add in a hydrogen that should not be there. Okay, no, it should be there. My word. There we go. Okay. Then, the problem with what I've just drawn, and this is something you'll see often, okay, is that H is actually in the wrong position. Because we've got to make sure it still looks like it would be if we drew it properly, even though we do this slightly differently to how we don't need to have it bent, it still needs to have some sort of structure. So really, the methanoic acid should be drawn like that. Okay, so let's just make sure we do it correctly. Then we have to have our H2SO4 because that's our catalyst. Now we need to draw the propyl methanoate. So propyl, 1, 2, 3, then the oxygen, then the little carbon all by itself, and I'm about to draw in something that doesn't belong there anymore because that's gone. So this is a hydrogen, 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 plus water. Please, 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 please be careful when they say use structural formula. Everything that has got a covalent bond needs to have a complete structural formula. Okay? Please, at this point, you should now be able to do activity 2 on page 102 of your textbooks, questions 1 and 2. Moving on to combustion reactions. Now, this is really nice. All hydrocarbons combust in the same way. Combust means burn. Okay, so please remember, combustion means burning. So when we burn it, and in particular, we're looking at burning in oxygen. When there is complete combustion, we get CO2 because there's lots of oxygen present. It's very, very, very exothermic, gives off lots and lots of energy, which is why we use hydrocarbons for fuel. Remember, we use octane in petrol. If there's insufficient oxygen, we get CO2. Please, that is an incomplete combustion, insufficient oxygen. Keyword in tests is going to be whether they tell you you have sufficient or insufficient oxygen. Most of the time, they're going to tell you you have sufficient oxygen. Hardest thing about these sections is balancing the equations. So, we have 2 questions. Write a balanced equation for the reaction when propane burns in excess oxygen. They're saying write a balanced equation. This would be like in chemical formula, molecular formula, propane being C3H8, CnH2n plus 2 is its molecular general formula. Then we have oxygen. Because it's excess oxygen, we know it's going to give me CO2, and then we're going to get water. From here, it's about balancing. So, this might take us more than one go. We're just going to work with it step by step. Starting with the carbons. The carbons, I would think, let's put a 3 in front of that. So, that gives me 3 carbons, 3 carbons. I'm happy with that. If we now look, I've got H8, H2, that means I would need to put a 4 in front of that one. So now I've got 6 carbons. All right, we're happy with that. 3 times 6 plus 4 oxygens, that's 10. So this becomes 5. Okay, it is really important that you check your balancing here. Okay, these can get a little tricky sometimes, and don't stress too much if you struggle with the balancing. It's only one part of the question. Okay, so just we take it step by step. That one was pretty straightforward. Let's look at the next one. Now they ask ethane burns in excess oxygen. Okay, so ethane is C2H6 plus O2, which is then going to give me CO2 and H2O. Great. Let's go back. 2 carbons, 2 carbons, 6 hydrogens, so I need to put a 3 in front of here. Now life gets interesting, okay, because 6 hydrogens, but now look what happens to the oxygens. I've got 4 oxygens plus 3, which means I have 7, okay. I cannot turn an even number into an odd number, but because of this 2, what I'm going to rather do, okay, is say, fine, if I could turn it into, if I wanted 7, I would, if I could multiply by 7 over 2, I would. But we know you can't because you can't have a half. So rather than that, let's multiply by 2. So I'm going to put a 2 here, okay? Now watch what happens. So I'm going to take away that 2, and I'm going to take away that 3, okay? So now I have 4 carbons, so I'm going to put a 4 there. Now I have 12 oxygens, so I need to put a 6 in front of this. Now watch what's happened. 8 oxygens plus 6, so now I have 14, which means I can put the 7 in front, and if you go and check that again, that is balanced, okay? Now, once again, this is one of those things where really you take it step by step, use it as it comes. Please, the balancing is one of those things that you get used to. The more you do, the better you get. So, again, now you can go to activity 3 on page 105 and complete question 1 and 2.